How solar panels turn sunlight into electricity. What if the sunlight falling on your roof right now could completely power your home, your gadgets, and even your car? Every single hour, the Earth receives more energy from the sun than humanity consumes in an entire year. The trick is capturing it. That's where solar panels come in. Today, we'll explore how these panels turn sunlight into electricity, which countries are leading the race, who makes the most panels, and even how you could install them on your own rooftop. The science of photovoltaics. The magic begins with the photovoltaic effect. Sunlight is made up of tiny energy packets called photons. When photons hit a solar cell made of silicon, they knock electrons loose. These free electrons start moving, and that movement is what we call electricity. The electricity that comes straight out of a solar panel is direct current, or DC. But because our homes and power grids run on alternating current, or AC, the current must pass through an inverter before it can light up a bulb or charge your phone. Without the photovoltaic effect, the idea of solar power simply wouldn't exist. What are solar panels made of? A solar panel is basically a sandwich of materials designed to trap sunlight and move electrons efficiently. At the core are solar cells, most often made of crystalline silicon. A typical panel contains about 60 to 72 cells, wired together in series. On top is a sheet of toughened glass that protects the cells from weather, while a transparent layer called EVA holds everything in place. Behind the cells, there's a polymer backsheet for insulation, and finally, an aluminum frame gives the whole structure strength. Modern panels are remarkably durable. Many still work at over 80% efficiency, even after 25 years of constant exposure to sun and rain. Which countries use the most panels? Now let's zoom out to the global picture. The country that has embraced solar the most is China, with over 520 gigawatts of installed solar capacity as of 2023. That's more than 5 times the capacity of the United States, which has around 120 gigawatts. India has rapidly climbed to third place with over 70 gigawatts, while Japan and Germany complete the top 5. What's interesting is how fast adoption is accelerating. In 2010, Germany was the leader, but in just over a decade, China completely reshaped the global solar market. Today, some Chinese provinces generate more solar electricity than entire nations used to. Biggest manufacturers and the future. Behind this solar boom are the companies that manufacture the panels. The industry is dominated by Chinese firms such as LONGi Solar, Trina Solar, JinkoSolar, and JinkoSolar. In fact, over 80% of the world's solar panels are produced in China. Prices have dropped dramatically thanks to mass production. The cost of solar modules has fallen by more than 90% since 2010. Looking forward, the next wave of technology is already emerging. Perovskite solar cells are being tested with efficiency levels above 30%, compared to around 20% for conventional silicon panels. We may soon see solar technology integrated directly into windows, rooftops, and even cars, making clean energy almost invisible but always available. How to install solar panels? What if you want to install solar at home? The process is straightforward but requires careful planning. First, a site survey checks whether your roof gets enough sunlight and whether it can handle the weight of the panels. Then comes system design. How many panels you'll need depends on your energy consumption. For example, an average US home might install a 6-kilowatt system, which typically requires around 16 panels. Installation includes mounting the panels at the right angle, wiring them together, and connecting them to an inverter. Some households add batteries to store excess power for nighttime use. Finally, the system is either tied to the grid, where extra energy can be sold back to utilities, or set up as an independent off-grid power source. Once running, a system can reduce your electricity bills by 60 to 100%, depending on location. So that's the journey, from photons in sunlight, to electrons in silicon, to electricity that powers entire nations. Solar panels aren't just hardware, they're part of a global shift toward cleaner, cheaper energy. The sun delivers more power than we'll ever need. The real question is, how quickly can we learn to capture it?